In this video, we're going to talk about how to describe polynomial functions. So what is a polynomial function? It's basically a function that has a polynomial in it, like f of x in this example shown here. If you graph a polynomial function, you'll notice that the domain includes all real numbers for x, and the range includes all real numbers for y. So the degree of a polynomial function will be equal to the highest degree of its monomial terms. So in this example, f of x has a degree of 4. A polynomial function is in standard form if its terms are written in descending order. So for example, the fourth degree term you can see here comes first, and then we have second degree, first degree, and then the constant term which has a degree 0. So graphs of polynomial functions can have all sorts of different shapes. So a linear function which has a degree of 1 will look like a line. A quadratic function which has a degree 2 will look like a parabola. A cubic function with a degree 3 will look like this right here. And a quartic function with a degree 4 has this like W sort of shape. So we also talk about roots and zeros of polynomial functions, so I just want to clarify what these terms mean. The roots of the polynomial function are what you find by setting the function equal to 0 and solving for x. So for example, if we have f of x equals x minus 2 times x plus 1 times x minus 3, that's a polynomial function. If we set it equal to 0, we'll find that x equals 2, it's one of the roots. A value r is a 0 of the polynomial f of x if you plug in r to the function, right, f of r, and then it equals 0. So zeros are basically x values that make y or f of x equal to 0. So for example, if we have the same polynomial function, we would say that x equals 2 is a 0 because when we find f of 2 and we plug that into this function, that's going to equal 0. So we also have something called the fundamental theorem of algebra. What the fundamental theorem of algebra tells us that the number of roots of a polynomial is equal to its degree. Okay, and this is a very important idea. So this is why we spend a lot of time talking about the degree and how to find it. So for example, you can see here in this f of x that it has a degree of 3, right? Because that's the highest degree term. So that means that this f of x is going to have 3 roots. Okay, g of x you can see is a 4th degree polynomial. So that means that g of x will have 4 roots. So notice that how we can connect this to the graphs of the functions, okay? The number of roots is going to show us how many times it crosses the x-axis. So you can see here this linear function that has a degree 1. So now we know it has 1 root, and you can see that's why it crosses the x-axis at 1 point. The quadratic has degree 2, so we're looking for 2 roots, and you can see that it crosses the x-axis twice. Cubic function with a degree 3 should have 3 roots, and notice we have 3 places where it crosses the x-axis. Same idea with the quartic function, has degree 4, so should have 4 roots, and you can see that it crosses the x-axis 4 times. So like we said, the zeros are x values that make the function equal to 0. So what the zeros will tell you is it tells you the x-intercepts, right? Because remember, x-intercepts occur where the function is equal to 0, right? Because remember, the function is equal to y. So y equals 0 at the x-intercepts. So the zeros will tell you the location of the x-intercepts. So that's why I was able to use the fundamental theorem of algebra to tell you based on the degree how many times the graph would cross the x-axis. So you can also identify the zeros of a polynomial if you look at the table of values, right? Remember we said the zeros is anywhere f of x equals 0. Well, if you look at the right side of your table of values, anywhere f of x equals 0 is going to be the location of a 0. So now how do we find roots and zeros by graphing? So we're going to graph the polynomial, and then if you do this in Desmos, you can just click on the x-intercept to determine the coordinates. The x-coordinates of the x-intercepts will tell you the zeros of the function. So for example, suppose we're trying to find the zeros of the function x to the 4th minus 6x cubed minus 7x squared plus 48x minus 36. Well, what you'll do is you'll go to Desmos, and here I have a screenshot of what I found in Desmos, and if I just click on these x-intercepts, it's going to tell me the coordinates. So based on those x-coordinates of the x-intercepts, I can tell you the zeros of this function. This function will have zeros at x equals negative 3, x equals 1, x equals 2, and x equals 6. Okay, so it has 4 zeros, and actually you can connect this to the fundamental theorem of algebra, right? This is a degree 4 polynomial, so it makes sense that I would have 4 zeros. So now you can go ahead and pause the video and try doing this example on your own. So if you type this polynomial into Desmos, you'll see that it crosses the x-axis 3 times. So each of those x-intercepts tells me the value of a 0. So we have zeros at x equals -1, x equals 2, and x equals 5. Okay, notice that this does follow the fundamental theorem of algebra because I have a third degree polynomial and I have 3 zeros. So another thing that you may have noticed as we work through these examples is that a polynomial can be written in standard form or factored form, right? So in standard form, it's easier to identify the degree because you can see the degree will be the first term, right? So this leading term, this x cubed, tells me that it's a third degree polynomial. In factored form, you'll be able to identify the roots. So this here and this x cubed minus 31x plus 30 and x plus 6 times x minus 1 times x minus 5 are actually the same polynomial. They're just written in two different forms. So notice the advantage of factored form is that you can quickly identify the roots of the polynomial. So in upcoming lessons, we're actually going to learn how to take a polynomial that's in standard form and convert it to factored form. And that's going to help us identify the zeros. So how do you find the zeros or roots of a polynomial function? Well, what we're going to do is use the fundamental theorem of algebra to predict the number of zeros. Okay, remember that's going to equal the number of the degree. Then we're going to set the function equal to 0 and rewrite the polynomial in factored form. Then we're going to use the zero product property that we used back when we were solving quadratics in Algebra 1, and then that's going to allow us to set each factor equal to 0 and solve for the values of x. So just to remind you the zero product property, because I know it's been a while, if we have factors that multiply to equal 0, then you can set each factor equal to 0 and solve for x. Okay, because it's this idea right here. So if I say like a times b equals 0, that means that either a has to equal 0 or b has to equal 0. Okay, because the only way to multiply two numbers together and get 0 is if one of them equals 0. That's basically the zero product property. So when you do this for a polynomial function, the values that you find for x are going to represent the roots of the function. So remember, when you were solving quadratics, for example, we would take a quadratic like x squared plus 4x minus 5, and you set it equal to 0. Okay, then you would use your factoring process to factor this, and you would get x minus 1 times x plus 5 equals 0. And then in those problems where you're actually trying to solve, you would take this and break it apart into two equations, and you'd say, okay, well, x minus 1 equals 0, or x plus 5 equals 0. And then with a little bit of algebra, you can figure out that x equals 1 and or x equals -5. Okay, so that's the idea here with the zero product property. So for example, if we have this polynomial here and we say, what are the roots of f of x equals x plus 6 times x minus 1 times x minus 5? Well, remember, when we're finding roots, those are the values that are going to make the function equal to 0. So we would set the function equal to 0. So we have x plus 6 times x minus 1 times x minus 5, and that's equal to 0. Well, how do I tell the degree of this? Well, notice that here, this is like x times x times x, right? So this is actually going to be a third degree polynomial, okay? Because I have three x terms that are being multiplied together. So if I actually algebraically multiplied these binomials and figured it out, my highest degree term would actually be a cubic. So now I can use that zero product property. I have three things that are being multiplied. Doesn't matter how many terms that are being multiplied. As long as it's equal to 0, one of them has to be 0. So I'm going to say that this means that either x plus 6 equals 0, or x minus 1 equals 0, or x minus 5 equals 0. Okay, that's the only way to multiply these binomials and get 0. So now I just solved these three linear equations. So this first one I'd solve by subtracting 6 from both sides, and that's going to give me x equals -6. The second one I'm going to solve by adding 1 to both sides, and that is going to give me x equals 1. And this third equation I solve by adding 5 to both sides, and that's going to give me x equals 5. So I found three roots, and this is a third degree polynomial, so that's how it works with the fundamental theorem of algebra. So now you can go ahead and pause the video and try doing this problem on your own. So remember, to find the roots, we're going to set this polynomial equal to 0, and then solve. So remember, if these three are going to multiply to equal 0, that means that x minus 2 equals 0, x plus 1 equals 0, or x minus 3 equals 0. Since we have x times x times x, this is once again a third degree polynomial, and that makes sense because when we solve, we actually find 3 roots. So another thing that we can do is we can tie this into the factors of the polynomial. If we know that a value r is a 0 of the polynomial function f of x, that means that x minus r is a factor. So if you know the zeros, you can actually write the equation in factored form. So let's revisit this problem, okay? So this is the one we looked at earlier, and what we did is we tried to figure out what are the zeros of the function, right? Remember, we graphed it and we said, okay, well, the x-intercepts tell us the zeros. Well, based on those zeros, we can actually write the equation of the function in factored form. So remember, these zeros were x equals -3, x equals 1, x equals 2, and x equals 6. So what I'm going to do is I'm going to write x minus r, so each of these roots, so x minus -3. Well, remember that an x minus negative, we just go ahead and turn that into a plus. So that's going to be x plus 3. Okay, my second factor is going to be x minus 1, and then I have x minus 2 and x minus 6. Okay, so now this polynomial that I have right here in standard form, I can write in factored form as f of x equals x plus 3 times x minus 1 times x minus 2 times x minus 6. Okay, so that's how you use the roots to write it in factored form. So you can also do this if you have a table of values, okay? So here it doesn't give us a graph, it gives us a table and says, okay, well, here are my values for f of x. So we know that anywhere f of x equals 0, we have those roots, okay? So the roots of this polynomial will be x equals -4, x equals -1, x equals 3, and x equals 5. So let's go ahead and do x minus r to write the factors. So this is going to be x minus -4. Well, you know, minus negative, let's go ahead and turn that into plus. So we have x plus 4. Then we have x minus -1. Once again, that minus negative, let's turn that into x plus 1. Then we have x minus 3. And finally, we have x minus 5. So we can actually write this polynomial f of x as x plus 4 times x plus 1 times x minus 3 times x minus 5. So now you can go ahead and pause the video and try doing this example on your own. So this is again revisiting one of those problems that we did earlier. Remember, we were finding the zeros. So the zeros in this case are x equals -1, x equals 2, and x equals 5. From x equals -1, we can write this as x minus -1. Well, that's just going to turn into x plus 1. And then we have x minus 2. And then we have x minus 5. Okay, so when we write this in factored form, we have x plus 1 times x minus 2 times x minus 5. So sometimes polynomials can do something a little bit different. So what can happen is this student, for example, graphed the polynomial g of x equals x cubed plus x squared minus 8x minus 12. And he was trying to figure out the zeros. So he knows that it's a third degree polynomial. So based on the fundamental theorem of algebra, he said he's looking for 3 zeros, right? Which is correct. The degree tells us the number of zeros. Well, when he graphed the function, he can only find 2 x-intercepts, right? So you can see here it has an x-intercept at -2, 0, and an x-intercept at 3, 0. So he's wondering, where did the third 0 go? Well, what happens is some polynomials will have what are called repeated roots. Okay, and this ties into an idea known as multiplicity. So what happened is they didn't do anything incorrectly. It's just that this polynomial has a repeated root at x equals -2. So how do you know when this happens? Well, you've seen this before. Okay, remember when you were graphing quadratics, we talked about the 3 situations with quadratics, right? We said that a quadratic can cross the x-axis twice, right? Which is what the majority of our quadratics do, right? We say it crosses twice, so it has 2 roots. And then we said, well, there are some quadratics that just kind of look like they're sitting on the x-axis, right? And those have 1 root. So we have 2 roots, 1 root, and then we have those quadratics that kind of hover above the x-axis, and those have no roots. So it's just that idea. So that idea that we talked about where it had 1 root, that's where it had a repeated root. Okay, so if our quadratic, for example, when we factor it, looked like x plus 4 squared, that was a situation where we had a repeated root at x equals negative 4. So it's not that the quadratic didn't have two solutions, it's just that both the solutions were negative 4, right? Because if we do x plus 4 squared and we set it equal to 0, well, that's basically like saying x plus 4 times x plus 4 equals 0. And if we break it apart into two equations, well, we're solving the equation x plus 4 equals 0 twice, right? So that's how we get x equals negative 4 as a repeated root. So how do you figure out whether a polynomial has a repeated root, right? How do you know? Well, if you're looking at it in factored form, you can tell pretty quickly it has a repeated root. What'll happen is the factor that's associated with that root will have an exponent on it, okay? So whatever that exponent is tells you how many times that root is repeated. So for example, like here, you can see in factored form, it was x plus 4 squared. So that's why that root was repeated twice. So that's the idea of multiplicity, okay? So sometimes a factor will appear more than once in the factored form of the polynomial. The number of times it appears is called the multiplicity, and then the 0 that's associated with that factor will have the same multiplicity. So for example, here we have a factored polynomial, and you can see that x minus 2 will have a multiplicity of 2, right? It's going to be equal to that exponent that's on the factor. So that means the associated 0 at x equals 2 will have a multiplicity of 2. Okay, similarly, at x plus 1, you see it has an exponent of 3. So that factor has a multiplicity of 3, and then the associated 0 at x equals negative 1 will also have a multiplicity of 3. So let's try writing the equation of the fourth degree polynomial f of x that has the following zeros. So it has these 3 zeros given to us, but notice that one of the zeros has a multiplicity. Okay, so we have x equals 0, so that's going to be the factor x minus 0. X equals 2, well, that's going to be the factor x minus 2, but it has a multiplicity of 2, so I'm going to put an exponent on it. X equals negative 3, well, that's going to be x minus negative 3. So let's write this a little bit better. X minus 0, I mean, I don't really need to write minus 0, right? I can just write x. And then x minus 2 squared, and then minus negative, let's just go ahead and turn that into a plus, okay? So that is going to be the fourth degree polynomial, that's f of x. So you can see it's fourth degree because you have a 1x and then x squared. So x times x squared will be x cubed. And then we have an x, right? So x cubed times x will be x to the fourth. So now you can go ahead and pause the video and try doing this example on your own. So this is a sixth degree polynomial because x equals 4 has no multiplicity. So that's going to be x minus 4. X equals 0 has a multiplicity of 3, so we have x minus 0 cubed. Well, that's just going to be x cubed. And then we have x equals negative 3 with a multiplicity of 2. Minus negative 3, I just went ahead and turned that into a plus, and that multiplicity of 2 becomes an exponent. Usually when we're writing these polynomials, if we have like an x cubed term or an x term, we just pull it out in front. So that's why I rearranged this and wrote x cubed times x minus 4 times x plus 3 squared. So you can find the zeros of a polynomial function f of x by setting the polynomial equal to 0 and solving for x, or by graphing and looking for the x-intercepts. If r is a 0 of the polynomial, that means that x minus r will be a factor of the polynomial.